welcome everyone to the next episode of the AIM Media House podcast Simulated Reality. Today we have with us the Chief Data Scientist from HireVue, Lindsey Zuloaga. Hi Lindsey, how are you doing today?
Hey, I'm great. Thanks for having me.
So, Lindsey, we are going to talk a little bit about the innovation of AI and machine learning in the field of hiring, right? And it's a very pertinent topic, especially with some of the news that have made headlines in the last couple of years. A very important topic to kind of discuss and especially understand from a chief data scientist perspective some of the nuances, some of the considerations that need to be really taken care of while building AI around hiring, right? To start off with, can you tell me a little bit about HireVue and your role in it?
Yeah, sure. So HireVue has actually been around for 20 years, but we were really small, kind of growing up. And in the space, our founder was actually, kind of looking for a job in his MBA, and he couldn't get an interview at Goldman Sachs, actually, even though Goldman Sachs was just right across the street, basically, because Goldman Sachs didn't interview at his school because he went to a small liberal arts college. So Goldman Sachs was only going to interview at these big colleges. And he had this idea of, why couldn't companies open up the funnel more if they could interview more people by opening the doors to more people by shipping them webcams and letting them record themselves answering questions, and then being able to review those interviews more quickly rather than having to use resources to go to schools and only choose certain schools that they go to. So kind of a cool story, because Goldman Sachs is a big customer of ours now, and they recruit at way more schools than they used to because technology has allowed them to do that. But we pioneered the idea of this asynchronous video interview many years ago, and we built a lot of tools on top of that. And one of them is using AI or machine learning to assess video interviews, so assess the language that candidates use when they record themselves answering questions about competencies like on the job, questions around how they handled situations and with a difficult customer or things like that. And we have virtual kind of job tryouts and games and scheduling tools and coding challenges. So we built a lot of tools around assessing candidates and making the whole process kind of more efficient and smooth. So personally, I come from a physics background, actually. And like a lot of people in data science, I kind of, I came up before there was data science programs and data science majors. So like a lot of people my age, more kind of just from the STEM background, but picked up data science pretty easily with all the math that I know. So I never thought I'd be working in this field, but I've been at HireVue for about 7.5 years, and it's a really kind of an interesting space to come into as a more technical person.
It's intriguing how something that, some of the challenges that you face in real life, you can translate it into real life tools so that, a lot of people can use it. And given your role, and especially in today's world, in 2024, with so many advances in the AI, right? What are some of the challenges that you face when it comes to scaling AI solutions, especially in such a critical area of hiring?
I guess one of the biggest ones is just change management. Hiring has been happening for a very long time, and there are a lot of legacy systems that work a certain way, and people are used to things working a certain way. So changing how things are done can be difficult. And there are a lot of benefits, obviously, to coming into a well-established field. There are a lot of benefits, and I'll talk more about fairness and kind of expectations of how validity of these algorithms and how they should work. We know a lot of those things, and there are standards there that's helpful. A lot of data scientists don't have that in their fields, but on the other side of that is what people are used to and kind of what they expect and what they understand, and kind of the tech savviness of some of the users of these tools can be a challenge. So people understanding how the tools are used and that they are, how they're built, in our case, to support human decision making. We give humans a lot of information. We give them more data to make decisions with. And often, people come into it thinking this algorithm is going to hire someone for me, or it's telling me what to do, or it's going to take my job. It isn't built to do that. It's built to automate a lot of the really mundane tasks that are part of hiring. Like, we don't do this specifically, but a lot of companies do, like automate resume review, automate phone screen. We do that. Automate, assessing candidates. We do a lot of that, so that humans can spend more time speaking with candidates, selling them on what they do. They have a lot more data to arm themselves with when they make decisions. It changes their job. We're seeing that happen in a lot of industries. Like, it's going to change everyone's job. It's going to morph what you do, but maybe not the ways that you would assume.
Being cautious about some of these systems that are built, especially when it comes to hiring. I don't know if your tool does that when it comes to this. Do they assess facial expressions, or do they assess some of these things? Because different cultures can, bring out different expressions, and they may not mean the same thing. Especially so when it comes to judging, let's say, for instance, facial expressions or intonation, or some of the things when they speak, or the vocabulary might not be the best judge for hiring and identifying a good candidate. So does your tool do that, or how does it?
We don't do that. We have experimented with it, and we've done it in the past, actually. And what we saw was, because and there is some intuition there. Hey, you're hiring for a customer service role. How you express yourself with your face or with your tone of voice could be important. And you're absolutely right. There was a lot of research around. There was some early research that showed there's some universality behind facial expressions. And then, there was Lisa Feldman Barrett came out several years ago, kind of bringing together a lot of studies showing that there's some more nuance here, especially around certain facial expressions. They're not universal, and in certain cultures, this is a little, certain expressions are not widely agreed upon, and different, just kind of different levels of expression, obviously, among different cultures. And I think, we've always checked our algorithms for bias against demographic groups. But there's also issues with when you're looking at video in different settings, when people have different lighting. Are you getting good data from everyone depending on their skin color, things like that. Like I said, we were always checking to make sure we don't have vastly different scores among groups. But in the end, we found there was a lot of concern around using any video or tonal data. And the vast majority of the valuable information we were getting was from the actual, the meaning, the words that people were using. So the language was so valuable. And then obviously with natural language processing over the last several years, just getting so much better, we were getting the bulk of the value out of that anyway. A lot of times what people say is very well aligned with what their face is doing. So it was actually redundant information most of the time. It wasn't giving us a lot of extra information. So it was just a lot more concern than it was actually worth. And so we stopped doing that, for 3 or 4 years ago. We phased that out.
Moving on to the subject at hand, right? We're going to talk about a research paper. Can you first explain to our audience what is the diversity validity dilemma, and what was your inspiration behind doing research on this particular topic?
Yeah, this paper is in the Journal of Applied Psychology, which is an IO psychology journal, industrial organizational psychology. So my team of data scientists, we work really closely with a team of IO psychologists, which is a great synergy within our company. And we're very lucky that we have the resources and the time to publish in academic journals. That's not super common in industry. But this is a term widely used within IO psychology to get at, a lot of times these types of selection procedures, as they would call them. So some kind of assessment or some kind of procedure that you're using to hire is very predictive of job performance often has problems with what is called adverse impact. So it is often has problems with bias, or that's one way of saying it. And the reasons why can become kind of complicated. Like one way to think of it as you have certain kinds of measures of job performance. They may have problems with those. What did you define as job performance? Or it could be retention. It could be something quite subjective. You kind of never know where that data comes from. There could be socioeconomic status reasons, like that people scored higher, certain demographic classes scored higher on this test. For whatever the reason is, there's often some of the most valid predictors of these kinds of assessments also happen to have group differences in the outcome. So they refer to this problem as the validity diversity dilemma, or in selection procedures. And it just means that as you kind of tweak your assessment, you kind of have this trade-off. Like, you want to hire people for these certain outcomes, but if you maximize that, you might have problems with diversity. And so doing that mathematically is pretty interesting. And as IO psychologists have thought about this for a long time, but now we're using these much more complicated models and these machine learning algorithms to do what used to be more simple. We're kind of joining forces. And so the team that published this paper is half IO psychologists, half data scientists, and actually a brother-sister pair, which is kind of fun. The two first authors are brother and sister. One's an IO psychologist at HireVue and one's a data scientist at HireVue. But kind of bringing those two worlds together to look at two ways of kind of optimizing to preserve both of those things and get at the best of both worlds in that trade-off.
What is an IO psychologist?
Industrial organizational psychologists. So these are people that study the world of work. And specifically on our team, they study hiring, basically. And some, within the field, a lot of people study a little more broad than that, kind of the world of work and getting promoted and how you measure performance, and even further than that. But our IO psychologists are very focused on selection or assessment in the job hiring process.
Psychologists and data scientists came together to publish this. One of the things that I've always observed is corporations who are trying to imbibe AI into their work life. Many of them want to go AI first. So any solution they want to solve, they want to see if AI is kind of the first avenue to solve that particular problem. While they are very, very wary of some of the implications of them, especially in some critical areas like hiring or probably, let's say, customer retention or customer approvals, etc. All of them want to build ethical AI, but don't have an ethicist or a social scientist in their team, which I always found really weird, because I don't think technologists really understand ethics and ethicists really understand technology to the extent that each of them understands their respective fields, right? So firstly, it's really cool that you have both the stakeholders come together, where social scientists or psychologists and then technologists came together to build this. I also wanted to kind of summarize some of the things that you said in terms of the dilemma. So you're saying that essentially in the diversity-validity dilemma, you're saying that diversity, because machine learning or AI/ML is primarily mathematical models, there is always a trade-off in terms of diversity or validity. Is that correct assumption? So if we are going to give priority to diversity, then there are more sets of parameters around it, and if there is validity, then probably you are trying to narrow down on some of the parameters. Is that my correct understanding of the problem?
Yeah, I mean, it depends on the data set, but it is common with these types of data sets that we do have data where there's kind of this anti-correlation there, right? So some correlation between some job outcome that is desirable and and having that split along demographic groups, or you have some bias in the data for some reason. And it's hard because you don't have any other data, right? So you could have, and this is a known thing with like IQ tests, and it's debated why, right? Why is it that certain races score higher on IQ tests? That's a whole other topic of why that is. Definitely with job performance data, it's even more complex. Why did women turn over more in this job? Because it was an inhospitable environment for women. But we don't want the algorithm to be repeating the certain patterns that it's finding in the data. We want it to ignore those things. So there's some great things you can do mathematically to ignore, and there's, you've probably seen the headlines, like negative headlines for hiring, like, hey, if you just hired males in the past and you said, we want to look at resumes, and you are only going to hire males in the future. It's very simplistic, but there's obviously ways that you can say we don't want to exacerbate the bias of the past. So what are simplistically, what are the words in the resumes that correlate to being male? Please ignore those words. That's a very kind of simple idea of a kind of technique that would ignore certain input features that lead to bias. Yeah, so in the paper, we talk about the predictor removal is kind of a baseline that we set. It was something we'd been doing for years, and we know that others in the field were doing something similar. No one had published it, so we knew that we're like, okay, first of all, let's just set a baseline for how we've been doing it for a few years now, which is we have a bunch of language input features. They are BERT features, so they're neural net language features. They're a little hard to interpret. They're these engineered features, but they're going into the model. If some of them are, we're gonna look at each feature and say how much is it contributing to the overall group differences that are coming out. So we have Cohen's d. We're calculating group differences among all the pairwise groups, and we're saying how much is it contributing to that bias, and divide that by how predictive it is, like how big the model weight is. And then we're just going to rank those ratios for all the features, throw out the ones that are giving us a lot of bias and that are not as predictive. So we want to get just batch by batch, throw those away, rebuild the model, throw them out, rebuild the model, throw them out, rebuild the model, until we kind of get to a point where we say, okay, this is a good point where every time we throw out a batch of features, we're losing a little predictive validity, but we're getting a fairer model, or model with less adverse impact. And then we kind of manually have to say where to stop. And so that's the way we've been doing it for a while. And then what we really wanted to highlight in the paper, which is the new way of doing it, which we saw was a lot better, which is, hey, we just add a term to the cost function and say, instead of going iteratively and building a new model every time, when we're building the model, when we have that cost function, rather than just incentivizing the algorithm to predict an outcome accurately, we're going to penalize it for having group differences in the outcome. So no manual stop needed. Just go, and we can kind of tune this coefficient to decide like how strong we want that penalty. But we can have that penalty built into the optimization. And what we see is as we tune it, as we have it run, we lose a lot less predictive value. We preserve a lot more fairness. So in the paper, we have plots that kind of show side by side, this validity versus diversity, two-dimensional plot, and with the two kind of approaches, and this new way, this multi-penalty optimization way, is much better. So it's very much a data scientist looked at an IO psychology problem and said, hey, like, it's math. Here's the cost function. You add a term, and it's quite simple, but it's a pretty simple and elegant solution to an old problem with bigger data sets than the IO psychologists are used to working with, classically.
Yeah. So the more you kind of try to understand the bias, the more you have to kind of check out some of the things, some of the parameterization or some of the features of the tool, so that you are removing those bias, but at the same time that is impacting your validation, but it is helping you improve the diversity in terms of some of the things that you're doing, correct?
Yeah, and in the first way I described, when you're removing features, you're killing off features completely, which, you know, that's pretty easy to understand. The second way is a little more nuanced because you're keeping all the features, you're just tuning them differently. So you could, it's a little more nuanced. You're saying we're not taking features away completely. We could say, well, this feature was a little bit biased this way, but it balanced out with this other feature. So we're keeping both of them in different weights, but it actually ends up being okay. So it's actually like not quite as easy to explain on the surface, but what it means is that you end up preserving that validity and keeping the algorithm a lot more fair, and so better all around.
So two questions here. So does that impact the accuracy of the model? So firstly, is there an accurate answer to someone finding the right candidate? Because it can always, it's not always black and white, right? Obviously, if there is one profession applying for another profession, then your model can definitely catch it and should be able to catch it, right? Like something as simple as that. But let's say there are two good, well qualified candidates, then how do you kind of differentiate? And second question is, you mentioned about the weights, right? What is the right ratio of weightage across parameters? How is that decision making? Can you walk us through a little bit of that?
Validity, I mean accuracy. I mean to say we're talking about how well do we predict out of sample, and yes, that is obviously hard to. Like any machine learning problem, you're picking some outcome, and it doesn't always include everything. It could mean we're saying, is it turnover on the job? Is it sales numbers? Is it some outcome on the job, or is it some score on a game, or some kind of assessment that someone took, etc. So everything kind of comes with a grain of salt. The more in this field, the more, further out you can measure someone's performance on the job, and the more objective of a measure that is, the better.
So how do you understand the reduction in bias, as well as who gets to decide the weightage and why, and what is the thought process behind that decision making?
Yeah, so it's all automatic, right? There's never any thought process. It's all within the optimization of the algorithm. So the algorithm is looking through this parameter space of, hundreds or thousands of parameters, and it's finding an optimal spot within that space. So it's saying, we're just as it would in a simple case where it's looking to say, hey, I want to predict the price of this house based on square footage and how many rooms it has, and if it has a garage or whatever inputs. No person is ever saying, hey, give it 2 points for having a garage. It's just looking within the space, and it's finding some optimal point. It's finding somewhere where it finds those weights where it can make predictions really well based on the training data. So same kind of thing. We're putting in this penalty where instead it wants to make predictions really well, but it also wants to do that without group differences. But in doing that, it finds the weights that help it do that well. That makes sense.
So for example, if there is a machine learning algorithm trying to detect whether a chest X-ray has pneumonia or not, right? And let's say it detects it. There's an algorithm for supervised learning. It has been given 1 million copies which are labeled to understand whether yes or no. It predicts it with certain accuracy. Now, if it predicts it wrong, then there is a penalty to it, and then the algorithm will readjust to kind of make its prediction. But when it comes to hiring, and especially with candidates that go toe to toe, right? There is no right answer, right, in terms of that. So how do you kind of decide the penalty for that algorithm to readjust its weights on parameters?
It's fair to say that often in hiring, we don't always get feedback on that exact candidate and feed it right back into the system like you would in the case you're describing, because often the feed that person may or may not be hired. We may or may not get feedback on them and feed it back into that exact algorithm later on. like in our system, we're often predicting something like, how well did this person answer this question? So unless a human, I mean, it's not always that we'll have ground truth feedback for that right away. We may get more training data later, and we're going to be retraining the model, and we will test out of sample. And so what we're doing is we're training on thousands and thousands of examples for one particular question, and we're testing out of sample and seeing how well we predict as an indicator of how well we'll predict on unseen data. But we don't have that immediate kind of feedback to, I mean, yeah, there isn't like any, in the case you describe, there isn't any like online learning or anything like that. Yes.
Yeah, but still, some of the aspects of it are very subjective, right? Even when you consider training it on thousands of data points from previous interviews or previous interactions between the person hiring and the person being hired, there are always subjective elements, whether this particular answer that the individual gave is it makes the person more qualified for the job as compared to some of.
Sure. Yeah. And I'll say a bit more about that. Like I used some very broad examples for the paper. What we do with video interviews is we're looking at competencies for the job, like I mentioned, ability to deal with a difficult customer or teamwork skills, where we're asking a question that it's pretty manual, that our team, and maybe this is what you're getting at earlier, our IO psychology team goes in and does an analysis of the job. And they say, this is a customer service role. These are the kinds of things you need for this role. We've interviewed people in the job. We understand what they do day to day. You need these competencies. We've built an assessment. These are the questions we're going to ask. And when we build the algorithms to score the answers to these questions, we had them reviewed by people who were trained to evaluate these answers. Each answer was evaluated by multiple people who have a rubric that is pretty clear, kind of what a 1, 2, 3, 4, 5 answer looks like. And if they disagree too much, we have to go discuss it. And so there's a lot of curation of the training data to make sure, what we're predicting is very clear, and that the user understands this is what we're predicting, because obviously, like, the best way to predict who would be good at a job would be to have them do the job and like for 3 months, and then you would know. But an interview is a proxy to that. So we're predicting how well they're doing in an interview, really, in this case, because that's a fairly good predictor. I mean, there's literature on that. Like, a structured interview is a fairly good predictor of job performance. That's been shown. And we do show that further down the line, that connection as well. But we have to be very clear with our customers too. What we're measuring here is how someone can talk about their ability to handle a difficult customer. And here's what a 3 out of 5 means in words, basically. Because it is, you're right, like, pretty subjective. And then there's also that connection, kind of how does that tie into the real world? There is, there's always inherently kind of that gap to bridge between the real world on the job performance and a job interview.
Essentially, especially in the field of hiring or some of these critical areas, there's an acknowledgement that while we can use AI to automate some of these things, or enable recruiters to kind of improve their processes, it's very critical to still have humans in the loop, right? There is very much a need for humans to kind of ensure that there is that. Where do you, in that entire hiring process, draw a line, and considering the responsibility that comes with it, right, or the ethics, where AI shouldn't take up the role of a human in assessing the candidate, and where do you see overall the future trends of AI being used in hiring?
I think it's definitely true. A lot of areas, humans and machines working together do the best job. So there's things that humans do really well, and there's things that algorithms do really well. How do we bring the best of both worlds together? Our tools are designed to work with humans and work alongside humans to give them more data, to give them more information to make decisions. So I think using them properly to what happens is humans come into our interface and they see their candidates there with the top tier candidates first. These are the people that are the most promising that you want to review first, because you maybe have hundreds or thousands of candidates for a job. So rather than letting 90% of them just disappear, let's start here at the most promising and work your way down until you find someone good, and then you have more data, more structure to the algorithm. And so I think, and then everything goes a lot faster as well. So I've been a job candidate. I know how miserable it can be to apply for a job and never hear anything back. We want the whole process to be easier and faster. But an understanding that yes, definitely there are pieces of this that humans play a very important role, and humans always make that final hiring decision. And humans, and human interviewing face to face or screen to screen is still the next step after assessment and pre-recorded interviews.
On that note, Lindsey, thank you so much for taking the time out. It's been fantastic to learn about your paper as well as understand the world of AI hiring today. Thank you so much.
Great. Good job. Thank you so much. Nice to talk.